Why the ionic compounds are generally soluble in polar solvents. Now look, from the Coulomb's law we get F is equals to 1 by 4 pi epsilon Q plus Q minus by R square. So the Coulombic attractive force, which is inversely proportional with the permittivity of the medium epsilon. So, with the increase of permittivity of the medium, the attractive force between the oppositely charged species decreases. So assume we have two oppositely charged species which are held together. Now if we increase the permittivity of the medium, that means we use different solvent which has higher permittivity, then the attractive force between these two charged species will decrease. So they will try to get apart, and generally they will be more soluble in that solvent. So look at this. This is the permittivity of water. This is CH3CN and this is NH3 ammonia. So the permittivity value for water is 82, for methyl cyanide is 33, and for ammonia is 25. So we can see among these three, water has the higher permittivity value. So in case of H2O, CH3CN and NH3, water is more promising to dissolve the ionic solids. So this is valid, this concept is valid only for the ionic solids, not for the covalent solids. So in case of ionic solid, water can easily dissolve the ionic solids. Now look, I have just shown the definitions of dielectric constant. Dielectric constant is the ratio of the permittivity of a substance to the permittivity of free space. If we write epsilon, that denotes the permittivity of the substance, and if we write epsilon 0, this is the permittivity of free space. This dielectric constant measures the ability of a substance to store electrical energy in an electric field. So dielectric constant epsilon r is equals to epsilon by epsilon 0. The very important effect of the dielectric constant is that it changes the speed of light. Now if c is the speed of light, this is inversely proportional to the square root of the product mu 0 and epsilon. So we get this relation c is equals to 1 by root over mu 0 into epsilon.